Time for Lip Online. Time for chemistry. So let's begin. Yesterday we were looking at a pure substance, and those pure substances, we said are those substances made up of one element, or it has one component. Generally, we said purity of substance can be determined by melting point, density, and the paper chromatography. So today we just want to explain how melting and boiling point can be used to identify purity of substance, and also density, mass, or paper chromatography. So let's start by looking at melting and the boiling point. The point is for us to determine whether substance is pure or not. So we said we can identify that substance is pure or not by using melting and boiling point, mass or density of substance, and pure paper chromatography. So let's look by looking at start by melting the boiling point in osmosis. So a pure substance has specific melting and boiling point. Any substance, pure substance has specific melting and boiling point. So mwakauti mu substance mo muli ma impurities apeza kuti boiling point imakwera kapena boiling point imatsika machisanzo madzi. Let's take water. Pure water tikapanga ice pure water amachita melt at 0 degrees Celsius. You see, tikutenga distilled water kumpanga ice, then mamachita melt apeza kuti by 0 degrees Celsius yekha azichita melt. Koma ukakati watenga tap water sisamakhala pure because amakati aikama chlorine kupasa makati mwina madzi ndokuda mlizina ndizina. That water is not pure. Tap water is not pure. Now ukatenga madzi amene aja kupanga ice yamatha kusukunuka even 0 degree isanafike chifukwa due to presence of my impurities. So munthu ukafuna uziona kuti kodi my substance is pure, choyena ndiuza kuti kodi substance boiling point yake kapena melting point yake ndi chani, ndio uitenge uchite boil kapena uchite melt at that specific temperature. Ukona kuti uchita at the exact temperature, just know that substance is pure. That's how we can use boiling point kapena melting point kudziwa kuti substance is pure. Water amwe tikabwera pa boiling point apataiza melting point ya 0 degrees Celsius. Water amachita boil at 100 degrees Celsius. Ndi ukatenga pure water kuchita boil at 100 degrees Celsius, boiling point ikafika 100 degrees Celsius, boiling point imapezeka. Imamba kuchita boil at 100 degrees Celsius. Pamene wakakuti water is not pure, imatha kuchita boil before 100 degrees Celsius or after 100 degrees Celsius. So that's an indication to say that water is pure. Similar applies to ethanol. Ethanol boils at 78 degrees Celsius. Ndimuka kuti muli ethanol muli ma impurity amene muli ma impurity kuchita boil at 78 degrees Celsius embeza kuti imachita boil before 78 or after 78 just due to the presence of impurities. So generally my impurities amachita affect the boiling point and also melting point of a substance. That's all about the impurity. Let's look at the density. Density of a substance. How can density of substance affect? If the density is higher or lower than the normal, then the substance contains impurity. Simple. The density, we say it's mass over volume. So it's relationship between mass over volume. So if the density of substance is higher or low, that's indicate that that substance contains an impurity. We should set much per paper chromatography. Per paper chromatography, experiment I think tunaipanga kai ku primary iliko. Kaona ba kaudi it is an advanced one, paper chromatography. What is paper chromatography, by the way? Paper chromatography is just a technique of separating mixtures of soluble substance. Technique of separating mixtures of soluble substances. So, more especially, it can be substances that are colored, such as food colorings, ink, dye, or plant pigment in chromatography are used. So, chromatography imakandi stationary phase, muscle mobile phase. So we have to have a simple picture of chromatography. Here is the procedure. How to chromatography, paper chromatography at home. It's possible to do this at home. So I'm going to read the procedure for you, and then I'm going to explain later. Using a pencil, zwanuri chromatography mechanical by phase, stationary phase. Using a pencil, start line is drawn near the bottom of chromatograph paper. The mixture is to be separated, is spotted on the start line. The bottom of chromatograph paper is dipped into the solvent, and the solvent travels up the paper. The solvent pick up the mixture, pick up the substance being tested and carry them up to the paper. The different component in the substance rise to different heights. So, procedure, I'm going to explain this procedure. Mujichewa kule mumvesesa bwino. Papepa chromatography chimene timachita. Okay, before I explain, how can we interpret that? How we have to interpret that chromatograph. So, my procedure generally, this is what we actually do. This is what we actually do. My procedure chimena akunena jona kuti. Let's take this one. Titenga bigger. We can be bigger or can be container. Tidwa paper la. Let me be demonstrating. This is the paper. The paper. You see the paper. Ndeno titenga bigger. Ndeuti tikatenga bigger. For example, tenga bigger mo tige mo mass like that in the bigger. The paper layo titenge doti tisiye ngata papa. Ndeno not doti tisiye ngata papa like this. Nde maza akaruta afika ngatu. Okay. I'm going to explain once again. Under chromatography, what is actually done, it is like this. We're going to have a beaker like this. First of all, we'll have a beaker like that. Then, titenga paper mwe yankope. Oh, sorry. Titenga paper yomwe yankope. Tikatenga paper yankope. Ndekuti we have to dip it in chromatography. Titaika ink malonga like this. You see? Titaika ink yoteleo. Mkati mwa bigamo timaikamo, we can put ethanol and water like that. Tika mansumo. The paper yamba kunyoa. The paper ikamanyoa, you find uti paper ikamanyoa easy kwenda chochi. Mabelaki ikwenda ikoza kufika ngatapa. Kwenda kunyoa kufika ngatapa. By capillary action. So paper ikamanyoa inki episode is to kunuka. Ndeno mu inki muna muli makala angapo nde makala ja azita speed ngati hii kala ine kuzokonekera ngatapa ina kuzonekera ngatapa chimodzimodzi kopi lijali likanyowa mizere maoneka kuti yachidwa speed. So that's simple about a paper chromatography. So nde makala ja amakauti a speed inaika pamwamba inaika akuzokuta speed ngatatu akaita speed ngatatu ndo mazokuti okay substance sinali pure. Ngati unatenga ink ya black ndeuti makala masiyana ina kala blue ina kala red ndo mazoto okay ink sinali pure kwa mu ink ya black mo munapondo ni makala tatu ina ntundoto koma ukakhatua panga paper chromatography yako ukakhatua panga paper chromatography yako kukhanga tamene ilili mpeza kuti after kupanga doti wika apa itamba kunyowa inango kwera nkha pamozi nkha doti imozi mwe umazoto okay ndeuti substance ina lumu ndi imozi. So this substance makauti ilipiwa pamene ukabwera ngati start line yako inali apa paper ikunyowa yachita split iyi yellow color iyi bwera pa purple color bwera ndema so umu munali makala ngapo. You see, that's the indication to say this is pure substance. Pamene ndi impure substance. Chifukwa mumwe chita split into makala angapo, mumwe chita split into one. You see? So that's the implication of paper chromatography. Paper chromatography yake nimenelo. Ma procedure ndi awandawerenga pakalewa. Ma procedure ndi amene you read smartly. Using paper chromatography, ukhoza kuchita the fact that substance is pure, kamina substance it is impure, based on the outcomes, based on the results that we have found. So paper chromatography, we find the relative flow of value. Relative flow of value is calculated to say distance traveled by substance over distance traveled by a solvent. Actually, yankwatul makala in form of ratio. For example, if you can see here, a solvent ya figure. If you can see here, a solvent ya figure hapa. And then you say distance traveled by solvent over distance traveled by substance. So substance chatu E. So ukafuna kutupa relative flow ya hii mapanga distance traveled by solvent over distance traveled by substance. Ukafuna kutupa hii upanga distance traveled by distance choka hapa start line ukafika hapa divided by distance traveled by E. So that's how you find the relative flow. So distance traveled by substance over distance traveled by solvent. For example, this is a good example of A, B, C, ndoti dot yonaika pa A, ndiye yakuchoka pa A kufika pa B, yellow, kuchoka pa A kufika pa C, purple, kuchoka pa A kufika pa D, blue. Solvent hii ndichoka pa A kufika kumwamba huko, amena chita ndoti a solvent flow. So for component B to find the relative flow, B so is 8 over 10. 10 the distance traveled by solvent. So substance over solvent, so it's 8 over 10 for B. So if you can see at B, okay, sorry, the mistake chabe. B on the D, if you can see clearly, D yo, mama B kale D, but B kale D. So it's 8 over 10. And then the D in the 8, that's blue. That's 8 over 10. But many pa C is 6, C on the kale mwero, 6 over 10. But many pa D the 2 over 10, it must be 10. I mean 2. It must be, if it is D, must be 8 over 10. So generally, let me do some correction here. Here must be a papakale D. Sorry. Here must be D. People, we have to put it D here. Apamena papakale B, like that. So relative flow again, so you can know this substance is pure or substance it is impure. Interpretation of relative flow. A relative flow can be used to identify purity of substance. A pure substance has only one relative flow value. A many impure substance has more than one relative flow value. So that's it. Impure substance has more than one. A many pure substance has only relative one flow. Thank you.